Hi, this is Mrs. Barbara. This is Physics Chapter 9, Current Electricity, Video 3. Today's topic is Ohm's Law. The objectives are: know the equation for Ohm's Law, understand current is directly proportional to voltage and inversely proportional to electrical resistance, be able to determine current, voltage, resistance, and know power in a system with a single resistor. Be able to interpret graphs of relating voltage, current, and resistance. Be able to determine whether or not a particular object obeys Ohm's law. Ohm's law. Ohm's law states the voltage results in current flow. So more voltage means more current, right? Voltage is the supplier. Resistance opposed to current flow. That means more resistance, less current. So basically, Ohm's law says, well, I is directly related to voltage and inversely related to R. So R equals to V over I. So Ohm's law says the resistance is the ratio of voltage versus current. If V increases, I will increase, so the ratio stays the same. It's almost like mass. So, almost like gravitational constant, G, right? So when the mass increases, your mass increase, the gravity increase, the ratio is the same. So it's the same concept. So resistance is just a ratio. So resistance, remember, is determined by the type of material, the length of the wire, and the width of the wire. So resistance does not determine by the current, is not determined by the current or the voltage across that wire, because it's a ratio of voltage over current. When you increase the voltage, your current also increases, so the ratio does not change. So your R, resistance, does not change with your V or I, even though it looks like R is directly related to V and R is inversely related to I, but that relationship is only mathematically. In physical world, it doesn't exist. That is because when V increases, I also increases. Material obeys Ohm's law means the resistance of the material is constant. So resistance, R equals V over I. So this one really tells you the relationship between V and I. So when V increase, I increase. This slope is the resistance. Now V and I, this is called ohmic material. If the line is not straight, this is called a non-ohmic material. Sometimes it can go up like this, sometimes it's just can go up like that. So if the line is curved, it's a non-ohmic material. So R is the slope of a potential difference versus current graph. The resistance is constant for a metallic conductor at a constant temperature. So in this case, this is ohmic material. Graph I versus V and I versus R. So I can change with V. When V increase, I increase. In this case, the slope is 1 over R. Right? Current and the potential difference have a direct relationship. The slope is equivalent to the reciprocal of the resistance of the resistor. So remember when we talked about spring force and the elongation. So if in the y direction, if this is x, if this is elongation in the y, and in the x direction is the force, the slope is 1 over k. It's the same idea. If in the y direction, vertical is current and horizontal is voltage, the slope is 1 over r. So I versus R. I is inversely related to R. The bigger the R, the smaller the I. So that's the inverse relationship is a curve. Current and resistance have an inverse relationship. Let's take a look at this example. So series circuit, so we don't know what a series circuit is yet. You don't have to worry about it. You know the total resistance is 100 ohms and the potential difference is 200 volts. What is the charge passing any point in the circuit in 2 seconds. Well, if we know the voltage, we know the resistance, what we can find is current. So current is V over R, so current is 2 amps. So you have to find the amount of charge passing any point in a circuit in 2 seconds. So you have to find Q. Q equals to I times T, so Q equals to 4 coulombs. So this equation has 2 steps. First step, you have to find the current. The second step, you have to find the charge. Ohm's law has as a predictor of current. So current basically is directly proportional to V and inversely proportional to R. So when V doubles, I doubles. When R doubles, I halves. So that's the relationship. The current is directly proportional to the potential difference impressed across its end and inversely proportional to total resistance offered by the external circuit. So the greater the battery voltage, the greater the current. Two-fold increase in the battery voltage would lead to two-fold increase in the current. On the other hand, the greater the resistance, the less the current. An increase in resistance of the load by a factor of 2 would cause the current to decrease by a factor of 2 to 1/2 of its original value. Now check your understanding. Which of the following caused the current through an electrical circuit to decrease? I equals V over R. So when you decrease voltage or when you increase R, the current decrease. The current would decrease, yes. Next question. A copper wire is connected across a constant voltage source. The current flowing in the wire can be increased by increasing what? So voltage is constant. To increase the current, R has to decrease. How can you decrease R? Well, if you increase the cross-sectional area, then R is decreased. Next one, a circuit consists of resistor and a battery. Increasing the voltage of the battery while keeping the temperature of the circuit constant would result in increasing what? You see this key, the temperature. Remember, the resistance is affected by the temperature. So if the temperature is not changing, that means resistance doesn't change. This ohmic material is ohmic. So that means I is directly proportional to the voltage. That means current will increase. Resistance will not change because material didn't change and temperature didn't change. So the answer is A only, current only. Another example, check your understanding. A long copper wire was connected to a voltage source. The voltage was varied and the current through the wire measured, while the temperature was held constant, using the graph to find the resistance of the copper wire. So here's the voltage and current graph. We know the slope is the resistance. So here we go again, trying to find the slope. Slope is rise over run. To find the slope, we must use the point on the line, on the best fit line. So in this case, here, the top is a very good point because we know exact value for the top point. Its voltage is 20, its current is 0.8. Another very good point, we know exact value is 0, 0. So over here, this point is on the line, but we have to estimate its value. And maybe it's, what do you think? It's less than 5, but 4.5, you have to kind of guess. And even the current also, you have to guess. So the best 2 point is the points you know exact what value it is. So in this case, R equals to the slope is change of V divided by change of I. You have 25 ohm. Another example. A student conducted an experiment to determine the resistance of a light bulb. As she applied various potential difference to the bulb, she recorded voltage and corresponding currents and constructed a graph below. The student concluded the resistance of the light bulb was not constant. What evidence from the graph supports the student conclusion? So we talked about in voltage, potential difference versus current, the slope is resistance. So this is a non-ohmic material because slope is not constant. Next one, according to the graph, is the potential difference increased? As the potential difference increased, what happens to the resistance of the light bulb? Let's see, this is current versus potential difference. So the slope indicate 1 over R. As you can see, 1 over R is decreasing because the slope is getting smaller and smaller. If 1 over R is decreasing, that means R has to increase. What happens to the resistance of the light bulb? R increased. Okay, check your understanding. Sketch the graph that best represents the relationship between potential difference across a metallic conductor and electric current through the conductor at a constant temperature T1 and at a higher temperature T2. So we know how is water related to T1, the temperature? The quantity related to temperature is resistance. So resistance increases as the temperature increases. So at T2, resistance is increased. We know in V versus I graph, slope is the resistance. So T2 must have a higher slope than T1. So here, if this is T1, T2 has to be like that, has higher slope. That's it for today. Thanks for watching.